All right, so like I said, we are not going to be talking about rational functions today. We are going to be talking about or learning about a new type of function. It's got a cool name, like literally it's a cool name. It's called, or they are called, radical functions. Told you, it's a cool name. They're radical functions. Radical functions are pretty unique. There's a lot that goes on with them, but here's like the general format of a radical function. You know, like a radical, right? The sign in mathematics. So your functions are, for the most part, going to be looking like this. F of x, you know, some function is equal to the square root of x. So just our functions now, instead of being like fractions that we learned in the previous unit, they're just going to have the radical sign. The most typical one that we're going to deal with is the square root of some value. Not too difficult, but there is a lot to this that we need to, like a lot of, I don't know, foundational skills that we need to get through. The first one is we need to be able to really answer this question. What is a function? What is a function? What is a function? What actually is it? So a function is an equation that looks like this, of course, but a function, what it really does, a function, whatever that is, like be it 1 divided by x or the square root of x, or gosh, I don't know, maybe even like your y equals mx plus b stuff that you learned in algebra 1. Those are all functions. And so hey, a function, it takes an input. You put something into the function. And then the function spits out a unique output. You throw something inside of the function and you determine if there is a unique output. Put something into a function, the function spits something out. So I'll show you using Desmos real quick. Let me go to a Desmos tab, possibly. Oh, dang it. Not what I wanted. Desmos, D-E-S-M-O-S. Pretty much the greatest website in the world. So if we had a function, like, hey, maybe it's f of x equals, I don't know, what do you guys want to do? Maybe x squared. So this is a function because whatever I plug in, like if I put into this function, the input, if I input like 5, the function spits out 25. It's perfect. All well and good, huh? If I plug in like 3, spit something out. If I plug in 0, if I plug in, whoops, anyways, all of these inputs have an output. If I plugged in -5, I get positive 25. So this is unique because the inputs are different. Maybe I should have actually phrased that a little bit differently in our notes, but maybe it's kind of clear, hopefully. Those 2 points are unique. We don't want to get to the same spot. Good deal. So, sometimes there are graphs that are not functions. Like this one would not be a function. Let me erase all this. This is an example of something that is not a function. And I remember how it goes. X squared, AB plus Y squared. That equals like some value, R. See that? That is not a function. No worries. That is not a function. That is not a function because if I tried to plug something into this, like, I don't know, this value, 0.3, that one input of this 0.3, if I plug in 0.3, you see that? There are two different outputs for 0.3. If I plug in 0.3, I can get 0.954. And I can also get, if I plugged in 0.3, I could also get negative 0.954. So this is not a function. Okay? That one out or that one input had two separate outputs. We don't want that. That is not good. That means it's not a function. So the easiest way to really determine whether something is a function or not is this thing called the vertical line test. You might have done this before at some point in your academic careers. A function, functions always pass. Functions pass. Functions pass the vertical line test. Functions have to pass the vertical line test. So here's like exactly what I mean. If I had a graph that looked like this, and I sketched a function on this graph that looked like this, is that a function or not? Is that orange line there? I guess it looks kind of red on the paper, but is that orange line a function? Hey, so to test this, all you have to do is the vertical line test. Just get something straight up and down, and move it along the function. If it passes the function in more than one spot, not a function. You see, as I move this across, we only intersect the function at one spot. I'll keep moving across, still one spot, it's down here now. There is never a spot where I cross the function twice. All right, pretty clear, huh? Not so bad. All right, what about this one? This one right here, what did we say though? This one? It is a function because it passed the vertical line test. What about this one? I think you can probably already kind of infer what the answer is going to be, but I'll draw it anyways as an example. All right, so this function, what if I went like this? Would that be a function? Absolutely. But hey, what if I go like this? Absolutely not. This one is not a function. How do we know? Like right here, it's okay. I'm only intersecting at one spot. But if I start to move this vertical line over, you see like right here, that means it is not a function. There we go. That absolutely means this one is not a function. Fantastic. So let's practice this just a couple more times. Khan Academy. It's the other greatest website in the world. I don't know what's up with the green bar. But anyways, so here we got this graph right here, that blue line. If I try to do the straight line test and I got to like right here, I'd be intersecting at more than one spot. A vertical line would be intersecting like right here, right here, right here, right here, like indefinitely. So this graph, it is most definitely not a function, right? Good deal. Maybe this one is probably a better one. So what do you think about this? Would this graph represent a function? No, why not? At more than one spot, right? The vertical line would intersect right here, if I were to graph this, and right here. That means not a function. Fantastic. We'll just finish this up. Give me some bonus points. What about this one? Would this be a function? Absolutely. Absolutely. If I move the vertical line across the function here, I would only intersect at one spot. Good deal. What about this one? It's a cool looking function. But is it a function? It's not actually a function. Because like this one, this input of one gives me a bunch of different outputs. That's not good. I mean, it's not a function. Okay, fantastic. Feeling pretty good about it. You guys feeling good about it? Yeah, it's easy stuff, huh? Good deal. So that was one of those like foundation things that we needed to talk about before we actually learn what a radical function is or how to get a radical function. So, all right, this is going to be kind of rough. Bear with me here. It's not going to be that bad, just kind of rough. So, what's function? That was the really first talking point that I wanted to get through today. The next thing is inverse functions. Inverse functions. So inverse functions, all they do is swap the x and y values. Okay, so if we were to start with this function, f of x equals x squared. And I started to, plug some things into this function. If f of x is equal to x squared, that would mean if I plugged in -2, -2 squared is +4. If I plugged in -1, my y value, if I put -1 in here, -1 squared is just +1. If I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. And if I plugged in 2, 2 squared is 4. Now let's graph this too. Good practice. All right, let's graph this thing real quick. So for this function, I've got a point at -2, +4. -2, and then 1, 2, 3, 4. So I have a point right up here. And in this function, I have another point at -1, +1. So right here. I have a point at 0, 0, a point at 1, 1, and a point at over 2, up 4. There we go. That is the graph of f of x. That's the original function that we had. Now, what I'll do next is I have this other function. I'm going to call this other function g of x. And I'll just write it out using words for now. We'll learn like correct notation here in just a second. So g of x, this new function, we're going to call this one the inverse of f of x, the inverse of our original function. It's really easy to create too. I'll show you all about how to do it. And then we're almost done for the day. These are like all the things that I really wanted to get through. So the inverse. It's not so bad. Check this out. We have x, we have y. Now, an inverse, just as I said up here, what does it do to our x and y values? This -2 and this +4. What does the inverse do? Yeah, exactly. It should literally just swaps them around. So instead of being -2, 4, this first point is going to be at or -2. Yep. Fantastic. And we also have this one switches a little bit. Instead of being -1, +1, swap them around. So it's going to be at 1, -1. This one's easy enough. 0 gets swapped with 0. We have 1, +1. Nothing really changes for that. And we also have this point. It's not going to be 2, 4. It's going to be 4, 2. Awesome. Let's sketch a graph for this one. Let's sketch g of x. Where are these points at again? Over 4. 1, 2, 3, 4. Down 2. Over 1. Down 1. 0, 0. 1, 1. And I go over 1, 2, 3, 4, up 2. Cool. That is one of the nicest looking graphs I have ever made. All right, so going back to f of x, is f of x a function? Absolutely. What about g of x? The inverse function that we created, is it a function? Absolutely not. G of x is not a function. Hey, just like, once again, how do I know it's not a function? G of x. You know, huh? Doesn't pass the straight line test, or the vertical line test, I should say. Okay, how do you feel about this? Like, can you guys, if I give you a function, like a table, you have a pretty good idea of how to invert it, swap the points, and then graph it, yeah? Easy enough. Just take all the x and y values and just swap them around. All right, so there were 3 things that I really needed to get to today. One was this: what really is a function? The second thing was the idea behind inverse functions. And the third thing algebraically find the inverse function. Third thing, algebraically find the inverse function. So we'll go back to what we started with at the very beginning, maybe. Well, not very beginning, but like right here. All right, so when you're given a function rule and you're asked to algebraically find the inverse, there's some steps involved that I think will really help you out. What I would do first, always, is just replace f of x, because it's just a hard variable to work with and write it down, and it's got parentheses that might throw you off eventually. Replace f of x with just another variable like y. And I'll do that. Y equals x squared. Cool, cool. Hey, remember the definition for inverse functions? They literally just swap the x and y values. So to find the inverse function, we'll take the y variable, the x variable, and we're going to swap them. So the second step would be swap the locations. Swap the locations of x and y. Swap the locations of x and y. So instead of reading this as y equals x squared, I'm going to read this as x equals y squared. And then the third and final step here would be I was going to say solve for y, but maybe we'll just say isolate the y variable. So there's something with the y right now. There's something with it. Like it says y squared. I want to get rid of that square. Hey, any of you guys know how to get rid of the y squared? Square root it. The opposite of a square is a square root. There we go. There's our inverse function. Square root of x is equal to y. So I think we're just gonna stop there. I think that's probably good enough for one day. I don't want to make this like video too long or anything. Just one thing to keep in mind here is we started with x squared and we created, what did we create? The square root of x by inverting. And you can check that it's true. Like, hey, the square root of 4 is 2. If I put 4 into that function, it spits out 2. And your calculator only calculates the positive amount, but you know that the square root of 4 is also, because of course, negative 2 squared is 4. So there's actually 2 things there. Okay, it works. I put these things into my function and it'll spit these things out. Now, what we're going to do starting next week is make this a function. It's not a function yet, right? Because it intersects twice. But we're just going to essentially erase one of these arms. I'll show you how to do that or like the next time that we have class. But again, that's it for the video portion of this.